Hi, in this video we will learn about so-called piecewise defined functions. These functions are important in practice for us because these generate very good classes of new functions first, and we will see that while studying limits of function, finding limits of these functions are going to be a very important part of the course. Okay, what is a piecewise defined function? A piecewise defined function is a function which is defined by different formulas for values of x in different parts of the domain. So let me tell you in practice how you will see these ones. So you will see that there's a function and then there is one expression in x. So expression 1 in x, which, well, this is true only for x when x is in first part of the domain. Then there's another expression. Let me write expression 2 in x when x is in another piece, and this continues at least 2, but then there might be more of these functions. Let's see an example of this. So see the following functions. F of x, let me do this. F of x is x plus 1 when x is less than bigger than equal to 1, and when x is less than 1, then the formula is x squared. So this is usually what you will see in the books have written. And what does this mean? It means that when x is a number in the interval 1 to plus infinity, f of x is defined by x plus 1, just adds 1 to the x. And when x is in the interval negative infinity to 1, f of x is given by the formula x squared, and usually this is how you see the function appear. Well, the second example is a very important one. You have seen it before, but let us just write it in details. Absolute value function. What does absolute value function do? If it is a positive number, just gives us back that same positive number. But if it is negative number, it drops the negative sign and gives us the number, the positive part of that number. So this, the way it is defined is here. When x is bigger than or equal to 0, absolute value of x is the x itself. Positive number comes out. But if x is negative, we have to get rid of that negative sign. This can be done by multiplying the number by another negative sign. Negative times negative is positive. So this is the famous absolute value function. And these are two examples. And what is different about the piecewise defined functions? So evaluating function, how to evaluate piecewise defined function at a point x equal to a. So when someone gives you a piecewise defined function and asks you what is value of the function at a, first thing to do is first find out to which part of the domain A belongs. Is A, for example, in this case, is A bigger than 0 or A less than 0? In this case, is A bigger than equal to 1 or less than 1? When you find that, then plug in A into X of the corresponding formula. So if A belongs to the first part of the domain, you plug in A into X for the first formula. If A belongs to the second part of the domain, you plug in A into X in the second formula, and so on. So let's go back to our example. Use f of x. This is the one that we had above, so I'm just writing it again. X plus 1 and x squared. It was less than 1. And find the values given below. So the first one is what is f of 0? How about f of 2? What will happen for f of 1? And the last piece is find f of 1 plus delta x minus f of 1 when delta x is a positive number. Okay, let's go one by one. So here the value a is 0, so at 0, and we see that 0 is less than 1, so we need to use the second formula. Which in this case is, 0 squared. Second formula says whatever x is, you square it, and that is 0. F at 2, 2 is bigger than equal to 1, so the first formula is what we will use. So first formula says whatever x is, you add 1 to that, and you get 3. F at 1, you have to be careful here. 1 is exactly equal to 1, so it belongs to the first part, and as a result, we have to use first formula. And this is 1 plus 1 is equal to 2. Okay, so in this example, I like to have this delta x negative, this last piece. Let us do this one for negative. So for the negative one, okay, so what you need to see here is that if delta x is negative, then 1 plus delta x is going to be less than 1. So it means that this part we need to use first formula. Sorry, it is less than 1. Second formula for this part. Second formula. And f at 1, we already saw here, we use the first formula. And then subtract them. So here then result is, the second formula says whatever is the input, you square it. And for the f of 1 says, the first formula says whatever is input, you add 1 to that. And then you see that this is 1 plus delta x squared minus 2. Let us just simplify this one, and then you get this minus 2, which is delta x squared plus 2 delta x minus 1. So these are the function, as I said, especially when we study the limits, you have to know how to work with this one very nicely. And then, the definition was important, the way they are defined, and then how to evaluate them. And we reviewed those ones.